Alright, are we live? Hello, hello. Welcome, welcome. Hope everybody's doing well. Howdy. Got another problem here to take a look at. See how it goes. Just give me one moment here. Excuse me. Yeah, I'm a little tired. A little sleepy, a little tired, a little bit worn out, I guess. I don't know. There are so many things I don't want to think about. I don't want to do or think about anything, man. Just want to coast, you know. Just do a whole lot of nothing. Do a whole lot of nothing. Excuse me. What I do want to do, what I do want to do is take a look at this problem here. Also, we could listen to this song. I guess if we're gonna look at the problem, we don't have to listen to this song. Kind of wanted to listen to this, but can't do two things at once, can you? So let's look at this problem, see how we do, see if we can figure it out in a reasonable amount of time. What is it? Oh, yeah. See if we can figure this out in a reasonable amount of time. And yeah, I mean, we'll do that. We'll just do that. I have to go later. I have to go. I'm gonna go to a meeting with one of the groups from the congregation. So I guess for other people they would refer to it as church. I kind of prefer to use. I'm trying to change my language a little bit because a building's just a building, right? The church is actually the body of Christ as a group of people. It's not. Yeah, it's about the people. It's not about the building. So trying to change my language so it sounds, but it'll sound confusing to the world. So I could say meeting with the body of Christ. I could say that. That's fine. It's not how people typically say it, but so what? You know, they'll understand. As long as they understand, that's really the main point. Meeting with the body of Christ later today, and that's in a few hours. So I thought I'd put a little bit of time in, try to solve another problem in between. And there are things I need to take care of, but I don't want to do them. I just don't want to. I don't know what it is. Also, I've had this aching in my neck and my back. It's just, oh, it's killing me. I'm spending so much time at the computer. It's not that I'm spending too much time at the computer. I mean, it is, but it's also that I'm kind of hunched over all the time. And I really need to get like a standing desk so that way I'm not hunched over. I don't want to do that either. I don't want to do anything. I just want to suffer. Just suffer. You are given an m by n integer matrix heights representing the height of each unit cell in a continent. The Pacific Ocean touches the continent's left and top edges, and the Atlantic Ocean touches the continent's right and bottom edges. Okay. Water can only flow in 4 directions, up, down, left, and right. Okay. Water flows from a cell to an adjacent one with an equal or lower height. Okay. Interesting. Turn a list of grid coordinates where water can flow to both the Pacific and Atlantic Oceans. So I guess excuse me. Well, these corners, I guess, are always true. Are always in that set because it flows through, right? I guess by default, the Pacific water is here, and then Atlantic water is here. So I guess any grid position where both water flows can reach. Huh. So really that's just an intersection of sets, right? We could say, since it could include all of the, yes, this should be relatively easy. Since this could include all of the grid positions, this our worst case would be O of m times n algorithm. And I think pretty easily what you can do is find all of the, you can use like a fill algorithm, we'll call it, starting from each position, and the fill would be from that position, sort of, it's a flood fill. So you'd all of the, what do they call that? All of the, what's the expression I'm looking for? All of the positions that are reachable from that starting point basically would be in all four directions something smaller, and then all four directions something smaller. And so you'd perform this flood fill, and you'd have a set, starting from this bottom backwards L, and this sort of upside down L over here, up and to the right and up. And first you do the Atlantic Ocean to populate a set populate the set of positions that you can reach starting from any of these points. And by the way, the way that flood fill works, you don't need to rerun the flood fill from every one of these positions, because you could see 5 is going to reach 1, which is going to reach 1, and then it'll stop there. It won't go after 2, but it'll cover all of these already. Actually, it only covers this part. And then you could skip these 1s because they're already included. And so you'd have sort of a list of starting points, and then you do 2, and you also don't need to revisit any of the nodes you already, basically just don't revisit the nodes you already visited. So it doesn't really matter where you start. You could just go through all of them, and then it'll say, oh, this has already been visited, this has already been visited. 2 would then say this is already visited. 4 would say this has already been visited. 5 would try to visit 4 already visited, would visit this 4, skip this one, skip this one. 3, 1, right? The flood fill would kind of, there's a certain redundancy involved. So obviously just skip, try all of these nodes and skip the nodes that you've already visited. And you can keep them in a set, keep it simple. We could use a hash set if we wanted to, but we don't need to. It's not really that important, significant to be that much more efficient. We would need to create our own hash function for these pairs, but excuse me, that's not too hard to do. The STL provides some functionality where we could provide a hash function. So yeah, you would do that for the Atlantic Ocean. That would give you a set of points. And then you do the same thing on the other side for the Pacific Ocean. That gives you another set of points. And then you would take the intersection of those two sets. And that's it. And return that as a vector of vectors. And you're done. So, okay, let's do that. Should be relatively simple. So input heights 2, 1, 1, 2. Output would be all 4. These heights, output 0, 4, 1, 3. And we just need to make sure that use the inputs to verify what I just described is correct, if that's actually what we're supposed to be finding. Yeah, M and N is relatively small, so this shouldn't be a problem. It should be relatively easy. So is this 1, 2, 3, 4, 5? 1, 2, 2, 3, 5. Okay, yeah, this is the one. Okay, fine. And so output is 0, 1, 2, 3, 4. Right, 5, and this one's the other side, which is 4, 0. And then there's some things in between. 1, 3, 0, 1, no, 0, 1, 0, 1, 2, 3. So 7. Can we get to 7? Really? That doesn't seem correct. What? Huh? It looks like these are kind of shaded in a way that's clearly 5. 5 goes to 4, right? This Pacific Ocean can reach 5 and 4, and 1 and 5, and I don't know, not 5, but 1. Maybe I'm wrong about this. Yeah, I think I'm wrong. I don't think what we're looking for is what I just described. Why? Water can flow to both. Are you telling me we're talking about position where this flood fill is going to reach one of these two? Both of these? Somehow it could reach both of these? Is that what you're telling me? That's a slightly different. It's not that the water from this spot is going to go up to these positions. It's as if you were in this position and you sent water down and it would reach both. So clearly 7 is larger than everything, so its flood fill contains the whole thing. 5 is obviously makes sense. 4 you can go up to the Pacific Ocean and to the right to the Atlantic. This 4 also does that. But this 3 can't go past 4 or 5. Okay, that's interesting. So yeah, there's this kind of a wall that gets created here. And none of these can go up past this wall from the Atlantic Ocean. However, something on this, okay, so this is an entirely different question from what I thought, right? 1, 2, 3, 4, 5, 6, 7. It kind of looks like these are shaded differently. So is that 7? 1, 2, 3, 4, 5, 6, 7, without verifying what they are. Yeah, it kind of looks like you've got this diagonal here. It'd be 0, 4, 1, 3, 2, 2, 3, 1, 4, 0. Yeah, and then these other ones is 0, 3, and 3, 0. Not 3, 0, I'm sorry, 1, 3, or 3, 1. 1, 4, no. 0, 3, no, what is this? 0, 1, 2, 3, 4? 0, 1, 2, 3, is this 0, 3? Am I crazy? What am I doing wrong here? 0, 4, 1, 4. 0, 4. 1. No. I don't know if this is the X or the Y. I want to say this is row column. If this is row column, then actually 0, 4 is over here. 1, 4 is there. And 1, 3 is here, which makes more sense. And you have 2, 2. And then it's row, third row, 0, 1, 2, 3. 3, 0, 3, 1, 4, 0. It looks like row column. Anyway, so actually, you could do this in O of m squared times n squared time, which is actually still relatively efficient, which is going to be, what's that, 4,000 squared, so 16 million. Still efficient enough where you do a flood fill from each of these positions, and you just need to reach either reach this position. Well, you just need to reach at least one of these values in this set, and then one of these elements in this set, or and one of the elements from the other set, which obviously these are actually overlapping. So if you get either of these ones, you get both. That's really it. Yeah, you could do like a brute force flood fill, and that would be probably efficient enough for the running time. I want to say, what else do you have here? Kind of want to listen to the music. It's really good. Just have it playing in the background. There's probably a way more efficient way to do this, though. That being said. I just had my vitamins, and my fingers smell like vitamins. So I keep sniffing my fingers because it's just like a really pungent kind of smell. So what I'm thinking, I'm wondering if I could do a similar kind of a flood fill algorithm from each position, but what I would want to do now is figure out, can the Pacific Ocean, can this reach the Pacific Ocean, or can this reach the Atlantic Ocean? Those two properties at each point, and we'll do them one at a time, I guess. And you would say, while you're moving around, while you're checking each position, if you can reach a position that you've already checked can reach both, then you don't actually need to. You can stop there, right? You don't. Once you've reached that spot, then you already can reach the sort of desired position. So we can do that for the Pacific Ocean first, and then do the same thing for the Atlantic Ocean, and it'll be. Now the question is, right? You only check the ones that have a lower height, and if And so this one will be able to reach the Pacific Ocean if the at least one of the other positions can also reach it. So yeah, it's going to be dynamic programming, I think we'll do. So we'll have sort of just a Boolean set, true or false, for this particular value for that row column combination. And I think what you're going to want to do is, so 1 is always going to be true. So these are true by default, right? First row, first column. 1 doesn't touch anything when the FloodFill stops immediately. 2 goes to 1 and you're done. And I think a breadth first search is what you're going to want to do. You should not do a depth first search. So we'll use a queue. So we'll use iteratively use a queue. Push all of these nodes into a queue, do a level order traversal. And then all those neighbors that can be reached, put that into the next element of the queue. So for 2, all of these would be all of these would be immediately true. So you would probably just skip all of these. And then 3, and I think it's best to go left to right. So you would put, you push this into the queue, and it's empty. Then you push this into the queue, then it's empty. You push this in the queue. You could write like a subroutine and then call each subroutine in sort of a loop over all of the row column pairs, or row column pairs. But you really don't need that. I mean, you could just write the routine right in there. I think it's fine inside the double for loop. But anyway, so you'd have all of these, right? These all can reach Pacific, and then 3 reaches. Now 2. It's 2, 3, 4, and 3. The 3, 4, and 3 wouldn't go into the queue, and then this 2 would. So 2 would reach. So 2 would be true. Then 3, same thing. 5 wouldn't. 4 wouldn't. 2 would. 3 would. Both of these will give you true, and you're done. And so you exit early, right? I guess maybe what do they call that? I guess maybe a subroutine is better because you could just return true to terminate early. I don't know, I gotta think about that. But yeah, so you return true for 3. 4 also would be true because you have 3, 3, 4, right? 4 would return true, right? Because you can go this way. 2 is true by default. By default. 4, you would say it's true because it has either of these 2s. 5 is true because it has 4. 3 is not true because the only thing that you can reach is this 1, and this 1 can't reach anything else. And so 3 falls flat, 1 falls flat. And in fact, actually, you could even save a little bit more work by using 3 values instead of a true and a false. You can do a character and or I want to say 2 bits. Maybe better to use 2 bits. A vector boolean, 2 boolean, or a pair of booleans. And that pair of booleans would be, I don't know. I don't know if you really save very much using a pair of booleans because you've got to create that structure, that data structure. And I want to say if that data structure requires any kind of, like I don't know how pairs are built internally. I think pairs have like an address, which for memory, if they do, then you're better off just using an integer. After all, so maybe just we use a character, and it'll just be 0, 1, or 2, and or -1 is 0 and 1, and 0 means that it hasn't been touched yet. -1 means you weren't able to find anything. You basically returned false your search, and 1 means that you actually were able to get to the Pacific Ocean from that spot. So these will both give you -1. So then you won't need, because it's not 0 at this spot, you won't need to search it again. So so you'd save work on both sides. So if you get return true or return false, you won't revisit nodes that you've already searched. So in that way, we can guarantee that we do O of m times n, do a small constant number of times m by n routines, not routines, but we really only visit the nodes a handful of times, and each node doesn't get visited too many times. So that would give you O of m times n time for the Pacific side, and then you do this sort of symmetric algorithm for the Atlantic side. And then you can have two arrays. I think it's fine to use two arrays of characters, and then you just loop through the two arrays at the end and compare, and just for the ones that the row column pairs that have two trues, both is true for these two properties, then you return that as in the return vector. Yeah, a little more involved than what I was described before. How are we doing on time? 26 minutes. Oh, wow. Okay. Oof. But yeah, I think we could do it that way. I think that's fine. Simple, sort of a simple FloodFill based using level order traversal algorithm, and FloodFill based level order traversal using breadth first search. Yeah. What was I saying? Throw some sanity checks in here. Or we do heights not empty. Rows is heights dot size. Number of columns is heights of 0 dot size. I forgot what I was saying. Let's say Pacific. We want to give it the number of rows. It's going to be, and it's going to be the number of columns, and the size. Oh, and it's going to be 0. Yeah, initially 0. So, what was I saying? We have FloodFill. Yeah, a FloodFill O of n times m solution that uses O of n times m memory and uses a FloodFill based solution with level order traversal for a breadth first search, and that should do the trick. Yeah, that should do the trick. Something like that. And let me just check something here. I'm gonna lower the brightness here. Should be able to solve this problem. Have the sun right in my eyes relatively quickly. Shouldn't be too bad. Hopefully we were able to ascertain what they're looking for and resolve this relatively quickly. Do we want to use pairs? We could use pairs instead of row column pairs. Just thinking, it doesn't really matter. I'm not sure if it matters all that much. q, say while not q is empty, say standard q next q. I realize this looks a little confusing, but I believe this is the way to do it. So we have a next q, and we're going to say q is not empty. We're going to say standard vector of, just say v. It's going to be q dot pop, or no, q dot top, or front really would be, yeah, front pop. And then, okay, so get this vector v, q front, and pop from the q. And we're going to say for each direction, we're going to have ourselves do some directions here. So we have vector of, we could use pairs, that's okay. Int pairs directions, and I was using yeah, I mean this is fine. Could do that. So we do -1 0 0 1 or -1. Oh, it's actually never eat sour watermelon, right? I usually like to go north is the row, negative row. East is, don't change the row, but change the column. Never eat south. South is this one. And west is the other. Okay. Yeah, I think tie is fine. The other one is make pair. I mean, it's fine. They're all fine. Doesn't matter. I kind of prefer make pair because I don't like my tuples. I don't necessarily like my pairs to be references. I think it makes things confusing. I prefer them to not be references. So just make pair. Okay. And now we're going to say for const auto, we're going to use binding. So actually you can do standard tie of, can you do that way? Well, yeah, let's try it. So for const auto p or directions, and we'll say int dr dy. Can you do this way? Yeah, I think you can do this way. I wanted to use structured binding, which is, it looks like this. That's a little bit cleaner. And we say a new direction or new direction of R or new column. It should be drdc. New row is going to be R. Now, here's the thing. This V, we could say standard, so we could say int current R, current row, or current column, current row. Current row. Standard tie is equal to V, right? You can do, that's another form of structured binding. And actually you can say, You don't even need to do it that way. It's another kind of structured binding. So a new row is going to be the current row plus the change in R, and the new column is going to be the current column plus the change in the column. And now we can say if for Pacific, you've got something very specific. Let's see. This is taking me a while to code it, huh? 35 minutes, not too bad. Trying to do it under 45 minutes here. So now we have a few different possibilities. We're going to say, first things first, if Pacific is of this new row, new column, equal to 0, then we're going to do the following. Inbounds, what we can say also. It's another kind of a check we can do. Certainty. Actually, yeah, I guess it matters. It does matter. Yeah. Okay, anyway, so if inbounds of new row, new column, and hasn't been touched, you know, we haven't set this specific to a certain value yet. If we've already set it, then we skip it. So we say if to set to true, so we have a few things. So if Pacific, otherwise, actually, wait, hold on, we need to do, so first we'll do inbounds. Just check if you're inbounds. If you're inbounds, then we say if Pacific is equal to 1, then we continue and we say Pacific of current R and current column equals also 1. Else, if we're -1, same thing. Otherwise, if we're untouched, or 0, that's when we want to say, actually, I'm doing this wrong. This logic is incorrect. It's really, this should go here. This is actually for the current row, current column. Really, we just need to check if this is inbounds, and the other check is heights of new row, new column is less than or equal to heights of current row. We're going to put this on a different spot here. There we go. If those things are true, then our next queue is going to get a push of this can we do it this way? I don't know if we could do that. I know we could do structured binding to the left with the tie. I don't know if we can go the other way. maybe, I don't know. We could say new row, new column. Yeah, I mean, why not? Okay. Oh no! What did I just do? Oh boy. Okay, so yeah, so we push this new vector if we're in bounds and the height is lower. Push that into the queue. When we pop this queue for this position, that's actually what we want to check and say. That's a good question, isn't it? This is what I was saying before about like skipping. Huh. Mm-hmm. Few things to note here. Already visited. Specific of row column is not equal to 0. Continue. Right? Yeah, so really if any of these are 1, so if current of R, current of C equals 1, then see, that's the thing that's super confusing. You'd want to propagate what you found back. It's kind of tricky to do it when you're doing breadth first search. Just thinking here. Oh, I don't know, man. This is a little bit tricky. Yeah, this is definitely tricky. I don't know if you can propagate the way that I would like to without using a depth first search. That's the thing I'm somewhat conflicted about. Breadth first search makes some sense, but propagating the answer backwards once you've found it is not the most obvious thing. Also, not re-adding to the queue something you've already visited. So we do need to have like a visited set as well. Um, Oh no, man. Uh-oh. Uh-oh. No. Alright, we didn't make the 45-minute mark. No, sir. No. It's a little bit more challenging than I thought it was going to be. Yeah, because each time we visit it, we don't necessarily know. So we could just have an array of arrays for. We could have another sort of data structure that tells us whether or not the position we're looking at we've already visited, so we don't visit it again. That's fine. The problem though is once we've reached a position, we can write that a certain spot is sort of is the value that it is. But I guess the issue we run into is we want to write the starting point, that value, but we also want to write all of the things in between that got us there. Basically retrace backwards, I guess. The problem with performing a depth first search is that it just traverses like a huge amount of the tree of the grid potentially before returning. And this is a little bit easier to implement with depth first search, I think. I want to say something like we can encode a kind of a tree in that we can have an array that points to, like I want to say you could take each row column pair as like a node, and then each of those nodes could have a parent pointing to another node. And so you would sort of follow the chain up those nodes. Once you sort of hit water, you can kind of write all of those nodes. Or once you've hit a spot where you know it's not. Actually, once you've hit a spot where you know it's not, that's kind of tricky too, isn't it? Doesn't seem to make as much sense for the spots that you know they're not. Because basically you would hit pretty much the way you know that you can't reach is that the queue is empty and you haven't set the value yet. I guess you would trace the tree up again too, but you would only skip the ones that you've already set, right? And then you would also want to skip the ones that are not only the ones that are already set, but the ones that are -1s. Those would also be skipped in terms of like when you're flood filling, you know that you can't reach the water from there. So you'd prune those too. Those would already be visited though anyway, so you would skip them anyhow. So actually, in that case, we don't need. Well, yeah, in that case, we already have the true. Because we need the visited set, which is true or false. Then we also have the can reach water or not, true or false. We don't actually need this to be a character. This can just be Boolean. So everything will be false until it's true. So then, all right, because we don't necessarily know if it's true. We haven't really set Pacific yet, even though it's may have been visited, hasn't necessarily been set yet. If that makes sense. It's already queued up. Excuse me. Well, the question is, yeah, we want each pair to have a parent, and then that parent to be aware of its parent. So I guess we could do something like that where we have like parents as well. Now I'm thinking about building a node class. Now I just think I should build a node class and have a vector of vectors of nodes, node structs. I think so. We should probably do that. Just collect all this data into a node. So there's Boolean Pacific, Atlantic, and visited. All of them initially false. And then we have a parent. Or really it should be just a pair of integers, I think. Right, and yeah, let's try that instead. Just like grid. And I suppose it'll be number of rows, columns, just a node constructed there, or we'll do it this way. Doesn't really have a constructor, right? It's just an internal struct. All right. So now if visited, so we say if grid of R C dot visited, then continue. Right. Level order traversal Q dot insert. Now it's going to be a node. We're going to use nodes. Node of now here's a question. Let's do it this way. Can we do node references or node pointers maybe? Maybe node pointers. We're going to say grid of RC. How about that? How about that? See how that goes. Yeah, we're way over 45 minutes. That's okay. That's fine. Take some time to solve this problem. All right, node pointers, insert, not empty. We're going to have a next queue of node pointers. So not empty. Okay. Now we say currency, just node pointer, say n. It's Q front, Q pop. Now the idea is I'm going to set these values as we process each node. So I've got this node. We say if don't have to check if it's visited here or anything. I guess what we would say is, what do we do? I don't actually know. We process each node. My thinking is that, okay, you have a node and you don't necessarily know if specific of node so if this node's already been visited, or rather if this node if n Pacific, that way continue, or n Atlantic, right? Yeah, we can make this a subroutine and run it once for Pacific and run it once for Atlantic. Something like that, I don't know. We can figure it out. Maybe we'll just copy paste it, just run the code twice. Make Atlantic slightly different than Pacific. So this is like way more complicated than I was expecting it to be, by the way. It's actually really complicated, this approach. Have a node, want to add its neighbors if they're, so let's start with that. Let's start with adding the neighbors, right? Want to add that to the next level order traversal. We'll say we process the node here. We don't necessarily know what we're going to do with regard to processing. Add neighbors to queue. Okay, so we would say for each direction, current R, current C is, so Yeah, this node has a row and column position also. I think that's significant. Should be aware of its own positioning. We also don't need this to do it this way. Parent row, P row, P column, row, column. Yeah. So it's aware of its own row, column, and its parent row, parent column, right? So yeah, we'll be somewhat self-aware. You kind of have to make it self-aware. Doesn't necessarily have a parent. Node, column, parent column. In fact, actually, you probably want to do even better than that. You probably would want a node pointer to parent to do even better. Yeah, let's try that. I don't know about all this, man. Whoa. That's not what I intended. There we go. Yeah, we probably would just want this always to be the null pointer. Yeah, because we can kind of use that null pointer to tell whether or not we should keep going up the parent tree, or up the tree of parents, I guess. Sort of more like a linked list than a tree, but ends up creating like a tree of linked lists, I guess. Something. It's kind of funky how this is going to look like, but Civic landed, visited, parent, int RC. We want to make this self-aware. So now, okay, we'll get back to processing the node, but adding neighbors to the queue. We have this current R, current C. We're going to say int current R is going to be NR. Current C is going to be NC. And then we're going to say if inbounds and not visited of, so it's going to be grid of NR NC dot visited and not visited. If we're inbounds and we haven't been visited already, and the heights of these values are such that this new that where we're going to is a lower height, then we can add to this queue the node for that position. We don't need these, which is going to be NR and C. And we do need to set we'll call it X again. That's fine. There we go. Okay. So now for each direction, right, we actually can push into next queue. Yeah, we do that for each direction, and then we do that down here actually. Yeah, set queue to next queue. Right. What have we got here? What else is going on here? So Q equals next Q. This is how we add the neighbors if we haven't visited already. And processing the node, we want to say node visited equals true. We want to say if we actually would want to clear the queue as well. Yeah, what we want to do is so next queue dot clear, right? Oh, okay. I want to say it's cleared. Remove all the nodes from the queue. Could also just set the queue to an empty, empty the queue and break, right? And what'll happen is then this queue will be set to that empty queue, and this will break, and then you'll go to the next element. And what you're going to want to do is, so this is if n, so one or two things. So if this is for Pacific, if this particular position, so we actually want to set visited to true, set current R, current C to NRNC. If current row is equal to the first row, or the current column is equal to the first column, or grid of, or not invisible, but n, if this is Pacific, so n Pacific is true, then we found something specific. Now we want to say iterate through each parent, set to Pacific as well. So this is going to be kind of funky code to copy for the other side, but we'll do it this way. Iterate through each parent and set to Pacific as well. So we're going to say while n, parent, we're going to say node t equals n parent, while t, really could do a for loop even. T equals, so t equals t parent, right? And we're going to say t Pacific equals true. And I think that's all you need. I'm just thinking if there's anything else. Nothing really, no, that's all. So you process the node, check if it's specific or not, operate on all the parents, add neighbors to queue, x parent has to be set as well. That's going to be equal to n, right? This node. So we set these values. Indeed. Yeah. Actually, that's pretty much it. Kind of involved. If you visited already, then you skip. And you perform the same thing again, but this time working on the Atlantic side. So that would look like the following. We just want to say the only code that really changes here is we can run this as a lambda function and then just give it a true-false parameter between Pacific or Atlantic. So yeah, so let's do that. Let's make this a lambda function, this whole thing. We'll just call it flood check. Let's just say Boolean Pacific, and we would say if grid visited, continue. Or really return, actually. Yeah. Actually just flat out return. RC. So we'll say if Pacific, perform the Pacific check, which is here. Otherwise, so this is to avoid duplicate code. Or some degree of duplicate code. And this is the Atlantic check, which is going to be number of rows minus 1 for the row, and the number of columns minus 1 for the number of columns, or n is Atlantic. And then we're going to say, right, so we say each parent and set to Pacific as well, set to Atlantic as well. And we said in the next queue, yeah, inside here, I think that's the right thing to do to break. I'm wondering if you could just return. I think it's probably fine to do this too. You could just return as well. It'll kind of break everything. The whole routine will kind of terminate. So Pacific, Atlantic, parent, right? Slightly different depending on the value, and yeah, I think that's all you need. So you can do. So one thing is you do need to update the visited values. So we can remove this now. And instead you can have flood check. RC Pacific initially. You just need to update all of the parents. And, oh, by the way, all of these values, you've got to update their parents to. Oh, that's a tricky thing, huh? Well, once it's already visited, we're never going to visit it again, right? Oh, huh. How about that? That's a good question. Actually, we shouldn't. That's a tricky thing. Uh-oh. Running into some problems here. Maybe I should use a FloodFill. And the reason for that is recursive FloodFill. Because if we're gonna set all of the parents going back, then actually we want all of these to kind of terminate in their right places. Because once we set them to visited, then we're just not going to visit them again. So actually, I think I'm doing this wrong. Yeah, if we do a flood fill in all positions, what'll happen is, I mean, they'll stop pretty quickly anyway, each of these, but huh. This is so confusing. I need to go lay down. I need to lay down. I think I did this wrong. I think I did it wrong. Oh, wow. Oh. Mm-hmm. Yeah, man. Yeah. Oh, boy. Okay. Yeah. Yeah. About this. Huh. Wow. So, what was I doing? What was I doing? Forgot. Oh boy. Oh. I don't even remember now. Huh. Yeah, I was in the middle of thinking that I did this all wrong. which I think it did. The idea is that if you come to a spot that you know from there can reach the Pacific water, then you know the position you came from can also reach the Pacific water. So water flowing out from that spot can reach it. Now, what I was thinking was actually just forget all the stuff that I was just doing and just do a flood fill from each position, and then never revisit the positions that you already visited, which I think makes sense. Yeah, that's perfectly fine. And you can actually do both, the Atlantic and the Pacific. You do them both in one shot. The question is, so you just have Atlantic, Pacific visited. Yeah, and then what? And oh. So the issue is right. Performing a depth first search. For some reason, I thought that there was an issue with that, but actually that's fine. That doesn't matter because you're never going to visit any of the nodes again once you've operated on them. So yeah, that really shouldn't be an issue. Right. Actually, the property, whether or not you visit, is independent of whether or not they could reach the Pacific or the Atlantic, because it just has to do with the heights. And yeah, it's all relative to their neighbors anyway, so it doesn't matter where you started. Just yeah. So actually, recursive depth first search is perfect. Yeah, we're good. We're fine. We are perfectly fine. I don't know why. I don't know, man. I think if I realized this solution a little bit sooner, this would have been a lot faster to program. I think this is like a relatively easy thing to program. It just, I think I got a little confused. I think I got a little ahead of myself, a little confused. Excuse me, most of this is the same, by the way. It's code. So we don't need a grid, we need visited, Pacific, Atlantic, inbounds. Yeah, we can do a DFS or FloodFill, call it. Which we say sort of an RC position, and we're going to process and then curse on neighbors. So we probably should have kept some of that code actually. That's okay. DR, DC, directions. We're going to say R, new C. Inbounds of new row, new column. And visited of and not visited of new R, new C. We want to recurse. And we also want to say Boolean check equals false. We're going to say visited, not processes. Visited of our C equals true. We also if visited of RC. Could put the processing here too. We don't touch the nodes that have been visited already. So we actually don't need to put that here then. Keep it simple. We don't even want to recurse if it's not inbounds though. But actually that doesn't matter either. Both of those can be just kind of thrown in here. If not inbounds, or we visited already. It really doesn't matter. We do want to do one thing though. Check or equals F. Want to return a Boolean. And that's going to be, actually we do a pair of Booleans, right? Well, I guess, okay, yeah, that's interesting. Let me think about that. Oh, Now, yeah, that's an interesting question. It's a good thing we looked at this question. This is a kind of a tricky one because I'm having trouble with like running the FloodFill in phases, just do the Pacific and then do the Atlantic. I think that's fine. I think we should do it that way. That's like so much easier to think about. Or if we should do the FloodFill, try to do them both in tandem. Because I think the problem you run into is that when you return back through the path that you made, you're going to return if you hit the Pacific or if you hit the Atlantic, right? Technically. And you might only capture one of those paths. So I think you need to do both in two phases. I think it's the simpler. Even if you could do it in tandem, I think it's just too confusing to do it that way. So I think it's better off to just FloodFill Atlantic and then FloodFill Pacific. And just like copy paste the code. You could do also, so you don't have duplicate code, you can say bool Pacific, have a certain check for Pacific and then another check for Atlantic. So yeah, so we would say check false, check equals F, return check, right? Check each of these and you would say if any of these are true, and F is going to be NR, NC, whatever Pacific is, and F again, and we said visited to true, process if it's out of bounds, we just return. I think we return false in all of those cases. And by the way, and the one time we return true is if phase A, or we just call it phase, doesn't really matter. We say if, depending on the phase, if Pacific if row is 0 or column is 0, or Pacific of row column, then return true, right? So the thing that's tricky about this is Actually, we want to do this in different pieces. So the thing that's really tricky about this is that if you have a neighbor that you already visited, you actually do want to process that, which is really confusing. But what you want to do with that neighbor is check to see if it's already been set, and then return that. If it hasn't been, yeah. So that's really interesting. So one of these phases is for the Pacific, and the other one is for Atlantic. And whatever you return, you want to set that. So if the phase is Pacific, then Pacific of RC is check. Otherwise, Atlantic is of RC is check. And actually, Atlantic is the other side. Is number of rows -1, number of columns -1. So, yeah. You actually do want to check your neighbor. That's super confusing. But yeah, you want to check all of the neighbors. If you've already visited, if they already have a value of true or false, then you want to basically cascade those values up. Otherwise, if they've already visited them, then you don't continue because their values are already set. Pretty interesting. Now the thing that's tricky is we do actually want to set these to true or false. Now if you call like this guy 1, you call these, and I guess you return false for both of these, it would get set. Every value is going to get set to something. So you don't necessarily need to, yeah, I think this is sufficient to set everything, this part. But yeah, so you have a FloodFill with a phase, and then, yeah, it's recursive. And so we can call FloodFill for row, column, phase is true. We'll start with Pacific, true, FloodFill. And then we're going to say clear visited array, which actually you don't need to do that. You could just say which is just number row, really just the whole this thing again. We don't need that anymore, by the way. Also, whoa, didn't want to show that. This we could put at the end. These should all be false too. Yeah. Okay. Yeah. Okay, I should just do grid pool. So we clear the visited array back, and then we flood fill process positions that can reach the Pacific. The Atlantic. So clear the visited array, process them both, and then we want to say positions that can reach both Pacific and Atlantic will be pushed into. So I'm actually wrong about this, by the way. Yeah, I was wrong. This should be. You do actually need to set these. And the reason for that is when you're actually looking at this row, it's going to go right in here and exit immediately. Yeah. Yeah. So you do need to set those. Okay. Anyway, so right. Pushed into the return vector. So Pacific of row column and Atlantic row column. We're going to say ret dot push back standard vector ints, which I hope we can. I'll just do it this way. Result, or just v, we'll call it. Okay. Does it compile? That's what I'm going to start with. Of course not. Typically no. Wrong answer. No kidding, really? Huh. Wow. What? Oh. Actually, it doesn't really matter. Well, maybe I should be flood filling from the other direction. But this shouldn't really matter, I think. A whole lot of these don't belong there. Seems like they all don't belong there. What? No. 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 Alright. Okay. Let's find out what are we missing. What's the problem? So let's go. We'll do ones and zeros, right? So for each row, we don't really need that, do we? Can just do a simple new line. And we could say Pacific of row column. Excuse me. Next. What does this look like? You're telling me that it works for all of the Pacific ones work? That's not true. These all work. This one works, 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 that works, that works, that works, that works. All of these on the left side work. This one doesn't work. Oh, that's why. Of course, my FloodFill is wrong. Completely forgot. Did not even factor in the heights. Completely my mistake. Interesting. That's the one thing we do need to check here. The heights of the target. It's going to be less than or equal to the heights of the current position. That may have something to do with it. Oh, no kidding. And at that point, you do need to check if they're inbounds as well. Yep. We're going to need to check that there. There we go. That's a lot better. Well, there you go. Uh-oh. Okay. That's a lot closer. Not quite what we're looking for, though. Also in time. Oh man, we're almost like up. We almost went overtime to the point where I won't have enough time. I have to go soon. How much time do I have? Maybe half an hour? Let me see. I have 10 minutes to find the error. Hope that it's correct after I submit the error. Submit the solution with the error. I should probably do more test cases, but I'm in something of a hurry. If it's wrong, I'll just have to come back to it, I guess. Why don't we have these ones? There are some across that are. this one works. This one should also work, that one. Yeah, there's some reciprocal stuff going on here that should be there. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. What is going on here? What is going on here? Huh. What are we missing here? Visited, return false. Curse on neighbors. Gotta make sure that's in bounds. Gotta make sure this height is less than or equal to. Right, then you can check. And oh, I think the issue might be, I don't actually know. So for some reason this one doesn't give you a 1. And I want to say that's because you get to here somehow, and you would go, you'd say it's true here, and let's say you recurse here first though, and here actually checking this point, you would say, oh, it's true. I think that was the problem I was thinking about before, the issue I was having where I was saying you kind of want to do the full recursion first before you, like you do want to visit nodes more than once. Like this one we know is true. Let's just say we know this one's true, really because we can look up and see that's true. But we would visit this, and I guess you find that this is false, not knowing that this is, oh, that's the problem. Oh, that's the issue. So actually you want to do, for the FloodFill from the Pacific side, you want to do only up and to the left as you move left to right for your directions, and then FloodFill from the Atlantic side, you wanted to go down and to the right, up and to the left, down to the right for the directions, and you want to FloodFill the other way. So actually you want these to be different neighbor sets. And you do want to pick the direction you go in. Yeah, otherwise it gets a little too confusing, I think. The problem with that though is like up and to the left. Yeah, I mean, yeah, I guess so. I don't know. The problem with that though is like if you had to make a circle to get around to one place, you sort of wouldn't be able to do it, I guess. I don't think that's necessarily true. I don't know. But I don't know if I have enough time to code this. I don't think it'll be correct either. I have like 5 minutes to do that. We could try. We can see how we do. All right, so in that case, we're actually going to go, we want to go to the left and up, right? Up and to the left. So left and up. And this is right and down. So left and up. So we start at n rows, -1, and n columns, -1. And you set greater than or equal to 0. And smell something, I don't know what that is. Hopefully it's not a problem, because I'm wholly unprepared to deal with the problem. It smells like a fire or smoke, something like that. The building does have a fire alarm, so I would have a warning to run if I needed it. And this is not the right spot. Okay, and the phase is going to tell us how we're going to loop through the neighbor set. So let's just say auto reference directions is going to be equal to phase. We'll say directions 1 or directions, yeah, Pacific, let's say, and then directions Atlantic. And so Pacific is going to be east and south. So this would be, so east and south are these two. And the ones that are left over are the Atlantic, which is north and west, right? So directions Pacific, directions south, yeah. East and south is Pacific. So depending on the phase, we're going to do Pacific is true for the phase, so Pacific. So directions Pacific, and then directions Atlantic. All right, what does this do? Does this compile? No, it's wrong. And nice. No, the Pacific is north and west. I actually have these mixed up. Does that compile? Hey, no, it's correct. Sweet. All right, we're gonna try. See how it goes. Probably won't be correct. Just gonna go for it. There's like no way it's gonna be correct. A little nervous here. Just take away all the debug code. All right. There's no way it could be correct. I gotta go through a bunch of test cases. There's no way. Let's try another test case. Let's try this one. See what happens. They're not empty, right? All right, let's go for it. There's no way it's right. Yeah, I was gonna say, there's no way. Yeah. I really needed to try more test cases, but I'm kind of running out of time here. It's really not a good excuse. Wow, dude, this problem would have. Yeah, I don't know, man. I struggle with these questions. These are like these interview questions. Unless you practice them, like you're gonna get nailed. Like some of these are just really challenging, I guess. So what are we missing? We have almost everything except for this 2-1 is missing. I really gotta go. I don't think I can fix this. I think the algorithm I have is just wrong. I think there's something special that I'm not doing that I should be doing. Or yeah, it's more complicated than this. Significantly more complicated than this, or something, I don't know. Or it's simpler and I don't have the right idea. So what we're expecting is we have almost everything. 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So basically these two and this one are the ones that we're missing. These three. And the suggestion is that actually one of these should be filled also. Which is which one? Expected 2, 1. 0, 1, 2. Row, column 1. Really, that should be a 1. So you could reach all of these from this 1, 2, 3, 8, 9, 4, 6. Yeah, that's the problem. Yes, because 6 can go 6, 5, 4, 3. Yeah, that's what I was thinking. If you had to go around somehow. Oh man. Maybe you just go over it twice. Maybe you do the algorithm I was doing before, but you just run it twice, and maybe that's it. Maybe it is that simple. Maybe that's all I need to do. That's pretty funny. I think that actually would work. Don't think too hard about it. Just run it twice. That would be very funny if that's the case. Okay, hold on. Okay, what do we get here? So this one comes out correct, but the other ones are not, right? Right, because the other ones have, I think, too many things. So what I want to do is actually, I want to run the FloodFill twice. Do it, yeah, do it for clear the visit array, reach the Pacific. Pacific again. Just do it again. I don't know, clear visit array. Process Pacific, reach the Atlantic again. I don't think it's gonna be correct. You know? This is pretty funny though. No, there's no way this is right. There's no way. Come on. Really? That would be really funny. You just do it twice. No problem. Problem solved. Problem solved. It might work for simpler examples, but more complicated examples, there's no way it works. Yeah. When things get more involved. No. Yeah, like this should really just work once in one direction, one case. I think the reason it doesn't work is, I don't know, I guess this is a problem I haven't seen before. It's kind of a complicated one. Not too complicated, but like the idea is really simple, but it's, like, yeah, it's sort of harder than, it's a variation of this problem that I haven't seen before, I guess, something like that. This is good. This is a good question. Obviously, if I can get the Pacific one correct, then I can get the Atlantic one correct, which it seems I haven't been able to get either of them correct. You could do just a straight out FloodFill, like where you perform once for each, your reset your visited set each time, so it's O of n m times n for each position, and a little bit, and I kind of terminate early, that if you see that this is already set to true, then you can sort of terminate early. That's kind of what I wanted to do before. But the problem is that I have this visited set that I want to use between each execution, And the issue you'll run into is that, like, for this 4, you would check this 4. Oh, that's why. Actually, no, we're fine. It's just, the issue is that because the heights are equal, oh, that's why I was so, that's my mistake. Okay, I gotta get going, but, oh, I see what I did wrong. This tripped me up too, last time too, with, there was another question where there was an equal sign that really made it way more complicated. I think it had something to do with the wiggle sort, the subsequences with the wiggle sort, or, no, it was actually the, oh, actually it's the same problem I haven't finished. It's the one, I solved it, but I didn't finish the really efficient solution. The interval, the inserting the interval, the reconstructing the queue problem, right? So I ran into the same issue where, because these values could be equal to each other, what this normally would be fine, what I wrote, however, because you don't ever go backwards from larger heights to smaller heights, so there's no reason to visit from the smaller height the larger height, because you already visit. Not only do you already visit it, but you're never going to go back to it because you can't go up. So, but when they're equal, when you have 4 and 4, when these two values are equal to each other, then you'll visit that spot. However, I guess what you want to do is don't set the visited set. Don't set this to visited unless you are actually processing the spot, I guess. And we'll just say, we could do like a skip visit, something like that. Skip visit, we could say. Now, this could be really inefficient though. We just want to say, let's just call it B. So if these are equal, skip visit equals true, or B equals true. I gotta go. So I think when the things are equal, we're gonna skip. But the problem with that is, you know, we did visit this parent. So you can have infinite loops now. Oh, it's so confusing. No. Oh man. Wrong. All right, we'll have to come back to this. Yeah, the issue is from here to here. You do want to add this to the visited set, but you don't want to put this in the visited set because this one relies on this one. So you can go backwards. So it's interesting because this one can go up this way and it won't make it that way, but then this one could go up this way too. But what's going to happen is this one's going to go this way to work, go this way to work, this way will fail, this way will fail, and then it'll mark these as visited. But the ones that are equal, And you kind of need to mark them as visited because in that particular iteration you don't want this to come back, but you don't want them to be marked visited for everything. So it's very tricky, I guess. Yeah, that's very interesting. The ones that are equal height, you got to be careful. I don't know what you do. I don't know. I have to rethink the algorithm altogether because this won't work for the heights that are equal. I thought it was so clever too. I thought it was so clever. That's what's got me tripped up. Okay. Ah, man, it's like these little subtle details that get you. Alrighty, let me go. Thank you all for watching. I will talk to you soon. Have a good rest of your day. Unfortunate, but is what it is. Not bad. Alright, so I'll make this part 1 and then we'll make a part 2 tomorrow, I guess. So yeah, thanks again. Talk to you soon. Enjoy the rest of your day. Take care.